Right now, somewhere in this galaxy, a star is dying, and when it does, it will not go quietly. It will collapse under its own weight in a fraction of a second and leave behind something the universe has no right to contain, a point of infinite density, a place where the laws of physics stop working, where space itself bends, breaks, and screams. Welcome to the most terrifying object in existence. Welcome to a black hole. Let us start with what it actually is, because most people get this wrong. A black hole is not a hole. It is not empty. It is the exact opposite of empty. It is the most densely packed object the cosmos can create. When a massive star, something 20 times larger than our own sun, exhausts its nuclear fuel, there is nothing left to push back against gravity. So gravity wins. The entire core collapses inward in less than a second. And what was once a star the size of a city becomes a single point, called a singularity, where density becomes infinite and our understanding of reality simply ends. Around this singularity is an invisible boundary, the event horizon. This is the point of no return. Cross it, and nothing, not light, not radio waves, not any signal in the universe, can ever escape again. You would not feel yourself cross it. There is no wall, no alarm, just a quiet, invisible line. And the moment you cross it, the rest of the universe is gone to you forever. You are inside, and you are never leaving. But here is what makes black holes stranger than any nightmare. They do not just trap you, they distort the very fabric of time around them. The closer you get to a black hole, the slower time moves for you, compared to someone watching from a safe distance. If you hovered just above the event horizon for what felt like 1 hour to you, thousands of years could pass on Earth. You would return to find everyone you had ever known long dead. Planets changed. Civilizations risen and collapsed. All because you got too close to something that bends time like a cheap piece of metal. And the death it offers, spaghettification, is one of the most visceral words in science for a reason. If you fell into a stellar black hole feet first, the gravitational pull on your feet would be so much stronger than the pull on your head that your body would be stretched out, vertically, into a long, thin strand of atoms. You would not be torn apart. You would be drawn out, like taffy, like pasta, into a single thread of matter, spiraling down into oblivion. The universe would literally make a noodle out of you. Now, if stellar black holes are terrifying, supermassive black holes are something else entirely. These are the monsters that live at the center of almost every large galaxy in the universe, including our own. At the heart of the Milky Way sits Sagittarius A star, a black hole 4 million times the mass of our sun. 4 million. And it is not the largest. The black hole at the center of the galaxy, M87, the one humanity photographed for the first time in 2019, is 6.5 billion times the mass of our sun. It is larger than our entire solar system. It consumes the equivalent of entire suns the way you consume a glass of water. But black holes do not only destroy, they also create. The jets of energy that blast out from the poles of supermassive black holes, traveling close to the speed of light, are some of the most powerful phenomena in the known universe. These jets can stretch for millions of light years. They pump energy into the surrounding galaxy, suppressing star formation, shaping the structure of entire cosmic neighborhoods. The monster at the center is also, in a twisted way, the architect. Black holes do not just eat galaxies, they sculpt them. And then there is what happens at the very end. Stephen Hawking, the man who stared into the mathematics of black holes, longer than almost anyone, discovered something that should not be possible. Black holes evaporate. Slowly, over unimaginable timescales, quantum effects near the event horizon cause a black hole to leak energy, particle by particle, in what we now call Hawking radiation. A stellar black hole might take longer than the current age of the universe to fully evaporate. The supermassive one would take a number so large it has more digits than there are atoms in the observable universe. But it ends. Everything ends. Even the most permanent seeming things in the cosmos are, on a long enough timeline, temporary. We have spent centuries imagining black holes as pure destruction, cosmic vacuum cleaners devouring everything around them. But the truth is more complicated and more beautiful than that. They are laboratories where physics breaks down. They are the universe's way of testing its own rules to destruction. They are the birth wounds of stars all too proud to die quietly. And somewhere, right now, one is pulling light itself into a slow, graceful, doomed spiral. Not because it is cruel, simply because gravity always wins. The universe is not here to comfort you. It is here to remind you how small we are, and how extraordinary it is that something as fragile as a human mind can look into the void, into a place where space and time themselves surrender and dare to understand it. Black holes are not the end of the story. They are the universe's reminder that the story is bigger than we ever imagined, and we have barely begun to read it